In this tutorial, we're going to learn how we can do logistic regression in SPSS. In particular, we're going to focus on the binary outcome. In this case, the difference between logistic regression and linear regression is that the outcome variable is dichotomous. For instance, it could be like success versus failure, yes versus no, or got admit to the program or not admit to the program. So as you can see, that only have two outcomes. So this is for the outcome variable, namely the y dependent variable. And for the independent variable in logistic regression can be like continuous or categorical or binary. Categorical include binary, yes. So there's not that much limitation, constraint in terms of independent variable, but for the dependent variable, it can be only binary for this case. In this tutorial, we're going to see an example which that we're going to see that whether student got admitted to the program or graduate program or not. Notice that this data is a hypothetical data, and I'll put a link down below to if you want to download this data to do some practice. And so this is basically the model. This dependent variable, these two are independent variable. And how can we do that in SPSS? You can click the Analyze, Regression, Binary, Logistic Regression, and got admit. Admit is the dependent variable. And we're going to focus on the GRE and GPA as the independent variables. In addition, I would like also to click you can click the option and then click the iteration process history. We're going to use that later. And click continue and OK. So this is the output. And the first table is say that okay, there are 400 observations. So in total, there are 400 raw data. And below that, there are two blocks. One is block 0, one is block 1. We're going to see one by one to see what they are. So the block 0 basically is that it doesn't have any predictors. It doesn't include the GRE and GPA into the model. It only had an intercept. And this is the iteration process. And remember that logistic regression uses maximum likelihood to estimate. This is different from linear regression where we use the ordinary least square. So this is the basic idea. And we can see that is -2 log likelihood. So basically, this is a measure of model fit. And the reason why it turns -2 on the log likelihood is because it's similar to, this is very similar, close to a chi-square distribution. And the number, when it's greater, it means that the model fit is worse. So this is a bit counterintuitive. This is the classification table. It predicts all the participants not admit. And for the observation, we know that in reality, there are 273 people not admit, but 127 got admit. So since that they predict all the people got not admit, the correct rate is what? Is 273 minus 400 in total, yes. We can do the calculation. So 237 divided 400. So this is 68.3, yes. So that's where this number came from. It's basically, it just said, okay, I put all the observation, I predict all the observation to be one category, which is not admit, and then see the percentage of correctness. And this is basically the model or constant, as we know that there's no predictors in the model. And this is the variable not in the equation. So basically, assuming that you will put this variable into the model, how it looks like. So both p-value is smaller than 0.05. It means that probably these two predictors we need to put that into the model. So this is where the block 1 came from. So the came from is block 1 is basically it put all the two predictors into the model. And let's see each table in this block 1. So this is again is a maximum likelihood iteration process. As you can see, the number now is 480. Remember, the number was 499. So difference is roughly 19.63. So that's where the second, so as you can see, the number becomes smaller. It means that the model fit becomes better. Yes, because we add two predictors into the model. So model fit in general overall should be better. So this is the stat block. Remember, we only have one block earlier. We do not have hierarchy regression. We only have one block, and we also this step, since they only have stat 0 and stat 1, so that's only one stat differences. So this is 19.633 is where it came from. It came from the 499.93977 minus the 480. So we can do it. We can check it like yes, 499.977 minus what's the another variable? 480.344. Yes, that's what so that's 19.633. That's the way it came from. Also, it has a name chi-square because minus 2 times log likelihood is close to a chi-square distribution. Okay, and degree of freedom 2 because we add 2 predictor into the model, so we use 2 degree of freedom. Model summaries. So again, this is the same for information because 480. That's where it converge the final number of the minus 2 log likelihood. And this is a table. This is different from the block 1. Block 1, remember, we put all the observation, all the participants into the 0 predict. But now we have different. We have also predict people into 1. So as you can see that, so the correctness, the percentage for the observation that are not at the mean, the correctness is very high. But the correctness for the people who go at the mean is pretty low because it predict most people go to not at the mean. But actually, those people should predict to go at the mean. But our model, it seems not very good to predict in terms of people go at the mean to the program. But it's very good at predict people not go into program. So and that's interesting. But remember, this data is hypothetical data, so we just use it as a practice. So don't read too much. But we just want to learn how to do logic regression. And okay, so now we go this final table, and this table is the most critical table. We would like to, in general, you want to report the final result, you want to look at this table. So before moving to the slide that I have prepared, let's just briefly look at this table. So the interesting thing is that both of them are significant because both the p-value is smaller than 0.05. So it means that GRE and GPA, both of them are important predictors to predict that whether people got into the program or not. Okay, so now let's move to the slide. I will show you how we can report the final result and what it means. And so you can write this into a model, a model statement. So remember, this is log likelihood. What it means is that it's the log of the mean probability of the mean but not at the mean. And so this is the what? This is the intercept, yes, 4.949, and this is the GRE predictor, and this is the GPA. And interestingly, there's a B and exponential B. What it means is basically, before moving that, let's just, I have prepared that to see what it means. So the regression coefficient. Regression coefficient means that if GRE increase 1 unit, then the log likelihood increase 0.003. Similarly, if GPA increase 1 unit, the log likelihood or log or ratio, I should be more precise. So if GRE increase, it should be log or ratio, increase 0.755. So that's the basic idea. And also, okay, finally, I would like to mention the difference between B and exponential B. So what's the relationship? This is very straightforward, actually. It's just like calculate the exponential of this you will got this. So that's literally what the column name tell you is exponential of the b. I think that's it. If you have any questions, feel free to leave comment down below, and I will do my best to answer your question. And thank you for watching. If you find this tutorial useful, please like the video and also consider subscribing to my channel. Thank you for watching.